This is problem 64 in your textbook. The speed limit in a school zone is 40 kilometers per hour. A driver traveling at the speed sees a child on the road 13 meters ahead of the car. He applies the brakes and the car decelerates at a uniform 8 meters per second squared. If the driver's reaction time is 0.25 seconds, will the car stop before hitting the child? Okay, so first we're going to draw a diagram. Label your known variables. Two things to note while writing these variables. One, you are given a velocity in kilometers per hour. You want meters per second, so what you need to do is change that to meters per second. It's going to be 11.1 meters per second. Two, you know that the acceleration, the object's slowing down, so it has to be negative acceleration because our speed is decreasing. So it would be negative 8 meters per second. We need to first figure out the distance in which our car is going to travel before the driver reacts and is able to press down on those brakes. So that's going to be delta x sub r. From t equals 0 seconds to t equals 0.25 seconds, you're going to have a constant velocity of 11.1 meters per second. So if your velocity is constant, that means that there's no acceleration, so you can't use big 4. You have to use instead v equals delta x over delta t. You're going to solve for your delta x. You know that v is 11.1. Solve for delta x. You should get 2.7 meters. 2.78 meters. Okay, so we found out how far our car is going to travel before we hit the brakes. Now we need to take into that consideration the constant deceleration rate, so we're going to use our big 4 constant acceleration equations to find our delta x. That sub v means braking, so the amount of displacement our car needs in order to brake and reach a velocity of 0. Right, because we want to stop, we know that our velocity, our final velocity is going to be 0. We can assume that our initial velocity at t equals 0.25 seconds is v naught, 11.1 meters per second. So now what we need to do is plug into a big 4 equation to find delta x. V squared equals v squared plus 2a delta x. V final is 0, V initial will be 11.1 meters per second squared. With a constant negative acceleration of negative 8 meters per second. We don't know what delta x is, we're going to leave it as a variable. 11.1 squared is 121. We're going to move that over to the other side of the equal sign. We're left with negative 123 is equal to negative 16 times delta x. Negative on both sides gives you a positive. Solve for delta x. you're going to get 7.7 meters is the amount of displacement your car will have while braking. So in order to get your entire distance that your car needs in order to go from that initial velocity, including the reaction time, to a final speed of 0, you have to add those together. Okay, once you add those two values together, we're going to get, sorry Felicia, we're going to get 10.48 total displacement from your initial position, and the child is 13 meters away from the initial position, so the car is going to stop in time, and it will actually have 2.5 meters to spare. So that is how you do number 64 in your textbook.